Okay, looking at example number 7, identifying the bias in studies. So here we have a study. We want to identify any flaws in the design of the experiment. So experiment A, a teacher wants to study the impact of music on testing. She gives a test to her Algebra 2 class in a quiet environment. Then she gives the same test to her geometry class, but this time with music playing softly in the room. The results. She found that the mean score of the test taken by the geometry class was higher than the mean score of the test taken by the Algebra 2 class. She concluded that the music is beneficial when testing. So we want to identify what is the control group and what is the experimental group. Okay, so the experimental group is the one that's doing the change, right? So experimental would be the geometry class, because it takes the test with music playing. So they're the experimental group. So geometry, while because the Algebra 2 class takes the test in a quiet environment, and the change the teacher wants to measure is the effect of the music on the test taking. Algebra 2 is going to be the control group. So this is the control. Algebra 2 would be the control group because they're not testing on the music, right? Okay, so those are our two control group and experimental groups. Okay, and then we want to identify any flaws in this. So think about, is there any flaws that we have in this experiment and control groups? Were they randomly selected? It doesn't look like they were randomly selected, so not random. And the two groups have more than one difference, right? So the one difference is not just the people in the class, but as well as there's more than one difference, right? There are two different subjects, right? So uh, more than two differences. So basically, you want everything to be the same except for the music, right? That's when you want to do a control group and experimental group. That's the only difference. But here we can see that not only is one getting music and one's not getting music, they're also different. The classes are different and they may have different skills, right? So there's more than two differences. We have music is one difference, even though I spelled music wrong. Whatever. Music and different levels of class, or different levels, right, with geometry and algebra 2. All right, so what can we do to correct this? So how do you think you could correct this mistake here? If I can scroll down here, maybe. Okay, so how do you think you can correct this? Well, could we just use maybe two algebra 2 classes instead of algebra 2 and geometry, or two geometry classes? Right, so the teacher could use a sample of geometry 2 students and geometry students that are similar ability. So maybe their grades are similar, and then randomly select members of the control group and select members of experimental group. So you could still do algebra 2 and geometry, but you could just, within algebra 2, you could select somebody with music and then somebody with not music, right? And then same thing with geometry. Somebody with music and somebody with not music. But how you control that within that as well is you could do maybe like grade point average or something like that. So you split them up in grade point average. People that have similar GPAs, you can put one with music and one with not music. And then in geometry, same thing, similar GPAs, one with music, one with not music, and you kind of eliminate your variables, right? Because the only thing that you really want a difference is just the music, right? So that's how you go identify the control and the experimental groups, identify any flaws, and then try to correct those flaws by limiting the differences, the variables.